Hi guys, this is a demonstration for our machine learning project. The goal of our project is to use machine learning to diagnose different types of dermatology diseases and the probability of making a definite diagnosis. The sample data set is acquired from UCI machine learning repository with around 400 instances and each has 34 attributes. The output have 6 different values, each representing a specific dermatology disease. The project we mainly used features engineering, feature selection, and multi-class classification.
The boosting from feature engineering is to look for the first four significant four features that mainly affects the output. The algorithm we use is through running the tuned bias first and cycle through each feature's weight by gradient descent method. The lowest weight result from whose well-tuned weight makes this attribute or feature the most significant one, and its corresponding tune weight becoming the first significant weight. After the first round of boosting finding most important attributes, we isolated this weight and attributes and go through the gradient descent method again, with the same approach finding the rest of significant attributes we need. When we look into the code, the four modes for boosting is shown here. While we tune the bias first by simply call a gradient descent function, then we isolated WS0 and tune for WS1 in this cell, and call the function argmin from numpy to find the index of minimum value. The corresponding header for this attribute returns to be age. The second round boosting was computed by isolating bias and feature age. With a similar approach, we have the second important feature here. We continue to find the third and fourth important feature by cycle the same algorithm. We then applied multi-class classification, including softmax, gradient descent, and fusion rule in our function to generate classification results. Two results from this algorithm are given, which are generated by boosting data and raw input data. The classification with boosting data will run much faster than the raw input, but we can see from the figure that there are only 8 misclassifications from raw input, but 160 from boosting. Both multi-class classification model returns probability of prediction confidence by normalize those distance of certain data points to a several class decision boundary.
At the end of this project, we created a GUI for users' ease. It basically has 34 input entries with respect to the 34 attributes. And here for testing, we already put in the first row of our original data set. And if we hit run without boosting, it will run the multi-class classification with all the inputs and calculate the probability. And the result perfectly matches what we have in the original data. And then we can hit run with boosting. It will use the top 4 most important attributes to implement the classification and give us another result. Most of the time, run without boosting is more accurate than run with boosting.